Okay, and this is an example 4 where we're going to work out the shear force and bending moments. And the first thing I want to do is work out the reaction forces at A and D. And to do that, I'm just going to reproduce the diagram just down below. So for the purposes of calculating the reaction forces, this is this load here is 30 kilonewtons per meter. It is 2 meters, so that's the equivalent of 60 kilonewtons. So 60 kilonewtons acting at the centroid of this, so that's 1 meter in. So that's that distance there is 1 meter. All right, so if I want to get the reaction forces, so if I take the forces about, say, D, so moments about D, we have the clockwise is, so it's RA multiplied by this distance, which is 3 and 2 is 5 and 1 is 6. So 6 RA, that's equal to the anti-clockwise, which is this moment here, which is 60 kilonewtons multiplied by, and what's that distance? Okay, so that's 1 meter and that's 1 meter, so it's 2. So RA is equal to, that's 120 divided by 6 is equal to 20 kilonewtons. Okay, and then we take the moments about A. And we will say the clockwise moments, so it's 60 kilonewtons. So it's this guy going that direction, so that's 3. That distance there is 1, so that's 4 by 4. That's equal to RD by 6. So that's 240. So RD is 40 kilonewtons. All right, so if we want to get the shear force then from A to B, so we'll just pick a segment in here. So the shear force from A to B is equal to 20 kilonewtons. And the moments from A to B is going to be, that's X, that distance there is X, is going to be 20 kilonewtons by X. Okay, no big deal. If we pick a point then somewhere between B and C, so the shear force from between B and C, well, that's going to be 20 kilonewtons minus, so in here, so what's that force? Okay, and we're saying the distance here now is, that's X, and that's this distance here is 3. So the amount that area there is going to be X minus 3. So it's going to be 30 times X minus 3. Okay, I want to multiply that out, I get, so what's that, 20k minus 30x plus 90, that should be k. So 20 plus 90 is 110 minus 30kx. And if I want to get the bending moment, so the bending moment from B to C, so that would be 20, let's forget about the k's, right? I'll put that in at the end. So that's 20x minus 30 times x minus 3. And that's going to be multiplied by the centroid. Well, the centroid of this then is x minus 3. Okay, so that's that distance all over 2. Okay, so that's what that distance there is, x minus 3 all over 2. And when we multiply that out, we get, I have done this before, so I have it written it down. So it's minus 15k x squared plus 110k minus 135k. They're all k up here. And then if I want to get from C to D, well, I know the forces on the left-hand side must equal to the forces on the right-hand side. So on the left-hand side, then we'll say that is equal to 20k minus 30k by 2. Okay, so 2 meters there, which is equal to 20 minus 60 is 40. Same as that guy, which is as predicted. And then the moment from C to D is going to be equal to, so it's 20k by x, and that's that one. And then this guy here is going to be minus 30k by 2. So that's what the mass is 30k by 2. And then that distance is going to be the centroid here. So that's 1 meter. So that would be x minus, so if that's 1 meter, then that distance out to there is 3 plus 1 is 4. X minus 4. And what's that? That's 20kx minus 60kx plus 64, 4, 6, 20, 240. Okay. So that's our bending moment. And if I was to put that into Excel and plot it, that would be my shear force, and that would be my bending moment between those points. Okay, that's the end of that example.